Hey everybody, I thought I would take a moment to try and explain problem 5A from the assignment that we just had. It was evaluating kind of your understanding of acceleration. There's a wide variety of answers that I'm getting and definitely some frustration that I'm experiencing from some of the answers that are coming from this. So I thought I'd take just a moment to make a video so you can help to kind of follow along with this on your own. If it all makes sense, don't watch this. But if you need any help at all, this might be a helpful tool. So I've got this equation or this problem that's here, and I said that you didn't need to kind of show your work on this problem, but I'm going to in order to kind of help you get there. And I'm actually going to use the strategy that I outlined in class before, which was this DGUESS, right? DGuess. So I'm going to work through this DGuess strategy here in order to make sense of the problem itself, so you know where to get started and how things work. So here's what the problem is, how it reads, and we'll go from there. It starts out, it says, suppose that an automobile were accelerating at 0.2 meters per second squared and could keep accelerating for 2 minutes at that rate. How fast it would be going after those 2 minutes. All right, so there's a few things to know here. One is that we can annotate the problem if we want to, which can be super helpful. And two, we can just start right out and do our drawing. So either way around, we could start by annotating, or we could start by just kind of drawing our picture out. I'm going to start by underlining a few things just to help me go here, so that we know that we're all on the same page. The pieces that are important to us start right up here, which is this 0.2 meters per second squared. That is a piece of information. And then the second one says is this 2 minutes that goes into it. And so this is two important pieces of information. This 0.2, I can go ahead and say, hey, this is an acceleration. And this 2 minutes is a certain amount of time, right? So that amount of time is like a delta t. So I've got an acceleration here, and I've got, that should be an n on that, excuse me, an acceleration and a delta t, which is an amount of time. So I suppose I could abbreviate that with the letter a, but this is okay. And then the last one, it still says kind of that 2 minutes. So I'm going to ignore that for just a moment. But it also says here how fast. This is the last piece of this, and this is what I'm looking for, right? So this is I don't know. So I've kind of highlighted the three things that I've got, and I can go ahead and start putting some information down on the page to help me out. So DGuess starts out with a drawing. So I'm going to go ahead and start out drawing my little automobile here. Your automobile, I'm sure, looks a lot better than mine, but I like to do little drawings here. And it's an automobile that was accelerating at a particular amount. So it's, let's say that it's moving in this direction. And I'm going to put in my my knowns right onto this drawing, because I feel like that helps me to be able to see things. And my knowns here is that I have an acceleration. So I'm going to put A equals, that's my acceleration. And I'm going to write in this 0.2, so 0.2 meters per second quantity squared. So this is my acceleration. The second thing that it tells me is a certain amount of time, right? So this is the other piece that I know. So I've got a change in time. And my change in time is 2 minutes. Now, immediately, bells and whistles need to go off in my head, because if I'm looking at these things in terms of units for a moment, there's something that would matter. And it's that this one here is in seconds, right? I can see the seconds. And this one down here is in minutes, which means that these two things are not highly compatible. So what we really need to do here is we need to make sure that these two things match up, because if we're talking about units of time, all our units of time have to match up for me to do any sort of mathematical work on these. So I know I have to make a conversion. Luckily, that conversion is not too hard. And I find that maybe the easier one of these conversions, right, is to not worry about seconds squared. It would be harder to kind of fix that, but it would be not too hard to fix minutes, probably. Which means over here, kind of on the side for just a moment, I'm going to go ahead and say, hey, 2 minutes is equal to how many seconds? Now, you can do whatever calculations you want to do here. You could do a stair-step method if that's helpful to you. You might also know that there are 60 seconds in every minute, and so this is a total of 120 seconds in 2 minutes. However you want to do the calculation is fine with me, but this is my conversion, and I need to pay close attention to the fact that this says 2 minutes here, but I really need to work it in seconds because it's in seconds up above. So I'm going to erase this here. I'm going to say, well, this same thing down below is equal to 120 seconds, right? So here's minutes, 120 seconds. All right. My eraser doesn't get small enough, apparently, to make it all nice. I wonder if I can do it a little smaller. That's okay. So let's go ahead and go from here. These are the things that I know. So what I've done so far is I've put in my D for my drawing, and I've put in my G for my givens. So now I need to write my unknown after that. My unknown is the last of my 3 pieces, and I already kind of highlighted up here. It says how fast. Well, what variable I use for how fast? I'm going to use a V for how fast. And my V I'm just going to put in as a question mark here. I don't know. I don't know how fast. Right? I could also put this in as a delta V, but it's the same idea here. The how fast as I be going after a certain amount of time. So I'm speeding up from whatever I was to what I am now. So we can use either a delta V or we could just leave it as a V. Either one works at this point. So now I've got my DGU. Now I need my equation. There's only one equation that we've been working with that fits the bill here, and it's the one that involves acceleration, time, and velocity. So the equation that I've got is the definition of acceleration. Acceleration equal to a change in velocity divided by a change in time. Right? So here I've got it. However, you know that when you use an equation, we do have to rework this equation so that it is solved for what I want. Solve for what I want. Now, I've talked about magic triangles before, but I'm going to go ahead and just look at this algebraically for a moment off to the side here to try and explain what we could do. So I'm going to rework this algebraically and say A is equal to a delta V divided by a delta T. And I want to, quote, solve this, right, for the unknown, which is the delta T. So I'm going to solve for delta T. So in order to solve this for delta T, I need to move delta T over to the other side. And algebraically speaking, that's not too hard. Right now, delta V is being divided by delta T. So I need to kind of do the opposite manipulation here, or opposite operator. And so I'm going to multiply both sides by delta T. And I'm going to multiply this side by a delta T as well, right? And algebraically speaking, when we do this, we say, okay, fine. I can now cancel my delta T on this side, right? That's all gone. And the only thing I have left on that side is delta V, which is what I wanted. And on the other side, I've got a multiplication of delta T and A. So I'm going to go ahead and rewrite this over here. And I'm going to say that, hey, now my delta V, that's this right there, is equal to, and then on the other side, I've got a delta T times A. I've just reworked the equation so that I've got delta V solved for. And that's really important if we're going to be understanding how to do this. So now I've got DGUE, and now I need an S. S is substitute. So let's go ahead and substitute in the things that we know. And I'm going to go ahead and do that here. So I'm going to say A equals, and up above, I actually have these two things. I've got an A, and I've got, not A equals. Silly me. Delta V, because that's what we're solving for, right? Delta V equals, and I'm going to plug in these two pieces here. So the first one is my delta T, which is 120 seconds. So 120 seconds. I've just substituted that in here. And then I'm going to substitute in for A. So I'm going to multiply this times what A is, which is 0.0 or 0.2, excuse me, right? 0.2. And this is meters per second squared, right? So here I am. I'm doing pretty well. I know that I've substituted the things in. So the last step in my entire process is this solve, right? So all I need to do now is multiply 120 times 0.2. I could grab a calculator, do that, or I can recognize that I could probably do this in my head. And I can say that my change in velocity, which is the answer I'm looking for, is equal to 24. And then meters per second squared times seconds leaves us in the units of velocity, which is meters per second. So my final answer here, right, is in meters per second. And this is my change in velocity based on that acceleration for 2 seconds. This is my answer, and this is what I would write down in the form. So I hope this was helpful to kind of see how things went. I used all of my guess to be able to get there. I did do some scratch work on the side, right? I did some conversion scratch work on the side, and I did an alteration on my equation on the side, but this is the whole work as a whole, and you can see what's going on. So hopefully that was helpful. And I'll go ahead and do the next problem in the next video. So maybe you can figure that out as things go. So I'm going to go ahead and stop this video, and we'll move on to the next one.